Welcome to the HIT tutorial series. This tutorial was developed by the Institute of Water Research at Michigan State University and funded by the U.S. Army Corps of Engineers. In this tutorial, you'll learn how to generate a HIT table, read a HIT table, and run different BMP scenarios. Note that if you do not know how to select watersheds, please watch either the Accessing HIT Data from the homepage video or Watershed Selection on the map. In a HIT table, you can access basic watershed information like HUC and acreage, tonnage estimates of erosion or sediment loading, and hypothetical BMP scenarios. However, there are some caveats. I'll run through them now. First, HIT outputs for these scenarios are not generated dynamically. They were estimated offline during individual watershed HIT modeling and stored in a database. Second, HIT's estimates of sediment loading and erosion are intended for relative comparisons between watersheds, not for precision. This goes for the BMP scenarios too. The reason being that, like all models, HIT has some limitations. Since it doesn't account for bank, wind, or gully erosion, observed reductions at monitoring stations would likely be greater than those reported in HIT outputs. This is why a relative comparison of reductions across watersheds would be more informative and appropriate. Furthermore, precise BMP simulations would be impossible to install in practice. For instance, no-till is implemented on entire fields, not within the individual 30 by 30 meter grid cells that HIT uses. Nonetheless, HIT can be a useful prioritization tool for groups and organizations that may not have the resources or expertise to utilize more thorough and robust sediment loading models. Now let's move on to how you actually make a HIT table. Whether you're generating the table from the homepage or the map, you're going to have to specify the information you'd like to obtain from the table. The menu will look like this. You can choose between erosion or sediment loading, totals or rates, and these 7 BMP scenarios. As you specify any of the BMP scenarios, you can adjust the BMP cost per acre on the fly here. Let's walk through how to generate a HIT table from the homepage. I've selected watersheds from the By Watershed tab. Now I'll select the Table button, make my specifications, sediment loadings and totals, and hit Make Table. The HIT table opens in a new window. Let's go over the columns. The first 3 columns in white describe basic information about the selected watersheds: name, HUC, and acreage. The gray column indicates the sediment loading totals. Likewise, had I selected rates, it would have also appeared with the gray heading. You can sort the table in ascending order by clicking on the heading of any column. I'll sort the table by the total amount of sediment loading. In this case, the Sandusky watershed is predicted to have the highest amount of sediment loading out of the selected watersheds. Now let's move on to generating HIT tables from the map. I've selected all the HUC 10 watersheds in the Sandusky HUC 8 first. HIT tables within the map are accessed through HIT Data in the toolbar. The table menu will pop up, and once again you'll have to make your specifications. I'm going to select sediment loading, rates, and a few BMP scenarios this time. Let's do no-till and grass on the worst 5% of a watershed. Now I'll select Make Table and view it in the pop-up window. Let's go over the new columns. The black columns show the estimated reduction in sediment loading for each BMP. The green columns show the cost-benefit of each BMP, essentially the bang for buck number. Notice that you can also adjust BMP costs on the fly here. Once again, I'm going to sort the table, this time by the BMP cost-benefit column for no-till. According to the HIT output, BMP dollars will go the furthest by targeting no-till adoption in the Little Sandusky River watershed, with an estimated cost-benefit of $17 per ton of sediment reduced under the scenario. That's all on HIT tables. The next tutorial will cover the Apply Legend tool. Thanks for watching.